on this side of the table.
No, you're
If the table was longer, we put you a little further away.
It's totally fine. Okay. All right, minimizing you guys. Okay, so I did the quiz already one time. And I have SPSS pulled up over here. Do you guys have the quiz pulled up?
I do.
Yeah. Cool. Well, 1 and 2 are true, I hope.
Two. I got you.
So with 14, so I did the prep assignment, but like I kind of just skip around to the questions that I know are going to be on the quiz.
Yeah.
And so a lot of it is just like concept questions.
Mm-hmm.
If that makes sense. So number 3.
Okay. Number 3, true?
Yes.
Okay. Number 4, requirements. I know the first one is 1, right?
No, the sample means are all positive is not 1.
Oh, it's
Yeah,
not.
it's the data in each group, and then variances are equal.
Okay.
Oh, wait. I thought the variances had to be, the largest one had to be 4 times, or the smallest one had to be like 4 times the larger.
So in the book,
Yeah.
because I have the book out right now.
Pull the book out on me, please.
Says there are 2 requirements that must be checked. The data are normally distributed in each group, and the variances are equal for each group.
Okay, so
and what I was thinking was the F statistic.
Oh, okay.
Yeah, because the F stat, that is what I was thinking. That's why I thought the sample means were positive.
Katie, what does it say in the book about the standard deviation or the variances being the square? I don't remember what it was saying exactly. Do you know what I'm talking about?
From what I remember, it's the variation of, or the largest variation, is that right, is 4 times bigger than the smallest variation.
Yes, that's what I'm thinking of. Okay.
And that's when you do all the work through SPSS, and it comes up with the different variations for each one.
Okay, so what it says is this. It says the rule that we will use is if the largest variance is less than or equal to 4 times the smallest variance, then we will conclude that the variances are equal.
Oh, perfect. Okay.
So if it's less than or equal to, then the variances
less than or
are
equal to 4 times the
Right.
smallest one, then they're just all equal. Yeah.
Okay.
Perfect. 5, check if each group is normally distributed. Do the following.
Histogram or QQ plot?
Mm-hmm.
Do you know which one it is? Either?
It's the QQ plot one.
Okay.
Mm-hmm.
Okay, number 6, we assume the variance in each group is the same if the following happens. And this is what you were just talking about, right?
Yeah.
The largest mean is the second one down. The largest variance is less than 4 times the smallest variance.
Yes.
Less than or equal to.
Okay. Do you have SPSS?
I have it open, yeah.
Perfect. Can you even see me? Is it like too dark? Does it look dark on my end, or is it just me?
You're just gray. I have other programs open on top of you guys, so I'm not looking at you too much.
So I don't know if you guys
basically.
For question 7, I just did that one on pen and paper with pen and paper. It's saying if you have 4 groups, how many pairs are there going to be? And so I just went through and I went 1 2 1 3 1 4 2 1 2 3 2 4, and it came out to 6. Does that make sense?
Do you know if you got that one right when you submitted it?
Yeah, it's right.
Okay. Hold on. Oh, yeah. You're right. 3, 2, 1.
And then you have to match the 4s. That's how there's.
2 samples. If there are only 3 samples, though.
Yeah, but like there are 3 pairs, 1 and 2, 1 and 3, 2 and 3. And if there's
And
4
it'd be
samples,
2 and 3, 2 and 2, and then 1 and or 3 and 3.
but if there's 4 samples, then there's the 4. There's
There's only
6
3
groups.
samples.
No, but there are 4 samples.
So if there's 4 samples, there's when you like write it all out, there should be 12 samples, but some of them are duplicates.
Yeah.
So with the duplicates left out, there's only 6.
You do the 3, and then you add in the 4s, and that gives you 6.
Okay.
Okay.
What is the minimums?
Wasn't this one in the book?
Number 8.
Yeah.
So the minimum for the variance of the 6 groups, I'm gonna pull up that data again. What data is that?
That's the soccer shoes.
Soccer shoes. Okay. I just finished the 14 homework, and so I have a bunch of different data pulled up. Like, oh, dang it. Whoops. To transform the data. I hope JJ makes it in time for the recording.
Yeah.
Okay, so what's the question asking?
The minimum or the smallest variance for the 6 groups?
So just for you guys, when you go into SPSS and you go to do the test for the ANOVA, don't forget to go into options and look at and add descriptive data and Q or mean plots, because that'll give you the Q graph, the QQ plot, and also the standard deviations where you can get the variances from.
Sweet.
Okay, so the minimum is the smallest variance for the 6 groups. So the smallest standard deviation is 5. Oh, JJ's on his way. 5.216. And so you square that. I got 27, what I just did, 27.206. 207 rounded.
27 or 20?
27.207.
Wait, so is that the largest one?
Is it the largest one on there?
No, that's the smallest one because it's asking for the minimum. So it's asking for the smallest variance of the 6 groups for number 8, correct?
Yes.
Yeah, so the smallest standard deviation is 5.216, and then you take that and you square it to get the variance.
Okay, I see what you're saying.
You said 5 point something.
I know,
How did it jump to 27?
Sorry, I'm making you guys
you reacted. I was like, okay, you're not reacting. Maybe I have it all wrong. No, you're good.
She's just crazy. She's going insane.
We just mute you and we're over here like, I don't know what's going on.
She's really crazy.
No, okay, that makes sense. And then the maximum, so you're just taking the standard deviation and squaring it to get the variance?
Yes, I'm taking the smallest standard deviation, squaring it, and then for number 9, you take the largest standard deviation and square it. Hey, Betty, what's up, man?
Wait, JJ's there?
Oh, I thought I was hearing you.
Oh no, I'm talking to my friends from my math class. You want to say hi?
I'm good.
Okay.
Doing and Callie yelling on the phone. I was
Oh
like,
no,
"God."
sorry. Hate to burst your bubble. I'm not Callie.
Oh,
What's up, Gilbert?
I thought. Hey, don't
Kiwi.
growl. I did nothing to you.
I have the dogs and my brother-in-law in here now, so we've got a party.
Well, sweet.
Okay, so number 9, we take the largest standard deviation, which is 7.291, and square it. And that is 53.159. Gilbert, stop.
He's not gonna stop.
I'll go chase shadows outside, huh?
Yeah.
And cute little kiwi too. Okay.
What was it, 59?
And then
53.159?
yes.
And then that
He's
divided
so
by
cute. He's autistic, and so he doesn't really understand sometimes.
because to see if the variances are equal.
They're equal,
it's
yeah.
less
so it's
than.
less than or equal to 4 times the smallest one. And
So
the
then
variance-
you take the smallest one, 27.3, or what did I just write it down?
27.207
Mm-hmm.
times 4, yeah.
So since that's 108, it's not equal. Right.
They're not. But
So-
I got that one wrong. I said, so for 10, it says the test for equal variances is satisfied for these data. And I put false and it's wrong.
Maybe it's just asking about the test. I don't know. Interesting.
I'm not sure.
So the test being satisfied is the test basically like the null hypothesis would be satisfied? Or the
For this one saying equal variances, I think it is it's the 4 times. But that doesn't make any sense unless I'm doing 4 times wrong, because 27 times 4 is 108, and 57. Wait, is it 57 is larger than that or smaller than that?
One more time?
So it's what's the rule again? The largest.
If the largest variance is less than or equal to 4 times the smallest variance.
Oh, well, it's less than 108, so then it'll be true. 53
Yeah,
is less than. Okay, so I read that wrong. I'm sorry.
or equal to. Yes.
Mhm. Okay, so that makes a lot of sense on the rest of these that I missed. I just read it wrong.
okay, that makes sense.
Does it really?
Yeah, I have it written down
Can
here.
we call them out?
Okay, this is how I wrote it down. The variance is large. The largest. The variance equals the largest is no more than 4 times the smallest. So you just multiply 4 times.
Yeah, as long as it isn't higher than 4 times the largest, they're gonna be equal.
Which is the great or the larger variance.
Yes.
The max.
As long as the max one isn't greater than
Mhm.
4 times, then they'll be equal.
Perfect.
Okay, so then construct a QQ plot. Each of the samples are approximately normal based on what you see in the QQ plots. True or false?
Is that false?
I don't see a QQ plot.
So the QQ plot I pulled up, and it's true for number 11. So when you do SPSS, that's when you have to go to the options side and hit mean plots, and then when it pulls up all the descriptive data for you, on the very bottom it shows up a QQ plot.
don't understand why it tells us to observe that the p-value is 0.080. Like it tells us what it should be.
You guys hear that screaming outside?
A little bit.
Just a little bit.
A little bit. Sorry about that. This is what happens every day. Okay, so what number are we on?
12.
12. Okay. So perform an ANOVA with SPSS. Okay, so on SPSS, it says the answer is 0.309.
That's with the SOX data removed.
Yes.
So you said 0.039?
0.309.
Dyslexic, guys.
That's okay.
I really am.
It would be to the right.
Correct.
Guys, we got onto hot dogs.
Okay, let me do this one over again. This is
Ew. Mostly pork and beef in hot dogs, but up to 15% poultry meat.
what's this data called?
DASL hot dog nutrition.
Thank you. Such random data.
So gross.
Okay, and what's the question asking? Okay, so question 14 asks, let's examine calories first. Construct a QQ plot of the calories for each of the 3 types of hot dogs and compare the variances to determine if the assumptions of ANOVA have been met. Okay, so I'll analyze this data. One-way ANOVA. Calories, correct, is what we're doing first. Okay, so the QQ plot looks normal. So it's going to be one of the first 2. I got this one wrong, but it's not B.
So it's safe to say that it comes from a normally distributed population.
And I think that they're equal. Yeah, so if someone wants to square this really quick for me, if one of you wants to square the lower and one of you wants to square the upper, I can give this to you.
What's up?
What's up?
What's up?
November?
Gosh, I just haven't had time to shave everything, so my mustache.
You did
Good. I'm busy.
Okay, so the lower is 22.551.
Okay.
And the upper is 29.383.
Sorry. Okay, so for the lower, I got 508.54
Okay.
or 548.
For the upper, I found my work for this from earlier. For the upper, I have 863. So yeah, you can conclude that they
Are equal.
are equal. Mm-hmm.
So
So then,
this is 14.
Yeah.
JJ, do you want the answers for the other ones?
Yeah, give me 1 sec. Okay.
First, 3. Yeah, 3 is true. 4 is the second. 5 is the last one. 6 is
While you guys are doing that, I'm gonna run a different test over here.
8 is 27.27. 9 is 53.159.
159?
10 is true. 11 is true. 12 is 0.30. 13 is right. 14 is the first one. 15 now.
Oh, NOVA tests are so fun.
Yeah, sure.
Do you need to pull up my SPSS?
No, I've got it.
Okay. Are you in a hotel room?
No, I'm in my fiance's sister's room.
Oh, it looks like a hotel room.
I wish. Not quite.
Just does.
I wish. No, a hotel room might be quieter.
How was it for that?
Okay. Did you get caught up, JJ?
Yeah.
Okay, so are we on 15 now?
Yes.
Okay, so it's not C. So we run a test. What does it say? Can someone read me 15 while I'm looking at the numbers?
Run an ANOVA test to determine if the mean number of calories is the same for all 3 types of hot dogs. You should find that the degrees of freedom are 2 and 51,
Okay.
that F equals 16.074, and that the p-value is 0, with a level of significance equal to 0.05. What conclusion can you draw?
Well, let me run that test again. So I'm getting my F at 1.771, but before when I did it, it pulled up as 16.074. So I don't know. Oh, for all 3 types of hot dogs. I just did.
Good that you shut up. No. Things. Because like when I texted you guys, I was just like literally looking at myself. You should
See, okay, and everybody's telling me I was crazy for it. Okay, that's all I'm saying.
Okay, but there's a soccer coach for the women's team that looks just like you, except he's bald.
So he
Like, I'm
doesn't
not
look
even
just like
kidding.
me.
Well, you have hair and he doesn't, but he looks just like you.
So saying he's a black man.
No, that's not what I'm saying.
We all look the same now? Is that what the heck?
No.
What's up with that?
I've had enough of this.
I'm done.
Biostat that, huh?
Did not say that.
I had that friend who lived in Mozambique, and he's just like, when I got there, I hated it. They all look exactly the same. And everything just. He's just like, oh yeah, he's just like, yeah. And then I was there like 6 months, and I started to notice a difference.
Yeah, there's some cultures out there that.
Hey man, like, you're Asian, you all cut your hair short,
Right. Don't expect me to know the difference between me and you and she and
anyone else.
whatever else they
What the
say.
heck is going on?
Okay,
Okay, so I just
that
realized that this one we don't need SPSS. We can just look at it. So with the p-value of being 0 and the level significance equal to 0.05, we can draw a conclusion just from that.
Right.
And so because the p level is less, we can reject the null. which mean we would accept the alternative.
So we fail to reject the null, or we do reject the null?
If the p-value is smaller than the level of significance, we reject the null, correct?
Yes.
So then we're accepting the alternative, which is they have a different number for means. And so the answer that I'm thinking is we do not have sufficient evidence to reject the claim. Wait, no.
Should be the last one. Right?
It's kind of
Yeah.
what I think.
I'm reading.
And that's one that it has in the book too. It's like almost the same thing.
We have sufficient evidence to claim that at least one of the hot dog types has a different mean number from the others. Yes. Okay.
I
That's what I
agree.
would say.
Um,
Now let's examine the sodium levels.
Woohoo.
Then let's
okay.
get
So
Seriously.
so the small is 7180 and the large is 10492. The problem
Yes.
says so those 10492 is within 4 times. So that's met, and then let me tell you the QQ plot looks normal. So the assumptions have been met, and it's okay to assume each group comes from a normally distributed. We can also assume that the variances are equal. So that would be A.
That's the only one that says the assumptions have been met. All the other ones say the
Oh, do
assumptions.
they?
Yeah.
That's funny. Like my eye was just drawn to that one because it said they didn't say not, and the next one said not. Didn't even read the other two.
I'm assuming that's a typo.
Oh, they just restructured all of these quizzes, so
Yeah.
Or they're just being really nice to us.
You can redo the text. It's a test. It's like, oh, that's a typo.
another guy who did it.
The p-value from
all three of
SPSS
them,
is 0.179.
Okay, this is where you said if it's equal to.
I said what?
Hold on. Remember we talked about the null alternative, and if the null
Yes.
says that it's equal to versus.
Okay, so if we're accepting the null, it says that all the means are equal with the ANOVA test. If you are accepting the rejection one, or you're rejecting the null, then at least one of the means differs. So since this one's higher than the level of significance, wouldn't we be accepting it that they all have the same mean sodium levels?
We fail to reject the null, so we are keeping it so that, yeah, they would all be the same. I put the first one down and I got it wrong.
Oh,
As soon as we all get on the same page.
Yeah.
just
You're right.
kidding.
We have sufficient evidence to claim.
So do they all have the same mean sodium levels?
Yeah, so we could say we do not have sufficient evidence to reject the claim that all 3 hot dog types have the same mean.
That's true.
It's probably that one.
I accept.
I'll submit.
Go for it.
I'll be feeling more.
Well, that's unfortunate.
That's awkward.
Like ready to go.
Did someone submit it?
Yeah, I did.
And
100%.
Yes! That makes me feel so good.
So can we just take like our exams together too?
I know.
I know, that'd be so
We're
hard.
done with group exam. No?
That's how I
Okay.
passed.
We can all have like
Math
half a sheet of
108.
paper.
Really?
Yeah, for Math 108, we did. It was an online class, and they let us do the final as a group exam.
That's sweet. Yeah, I know.
Yeah, so
So blessings.
Did they restructure M105 to be a group work thing instead of individual work?
yes, it's awesome.
I'm kind of jealous because like everyone gets like 100% on everything.
No.
Wait, did you say they changed Chem 105?
Yeah, so Chem 105, instead of like being lectured, you just do group activities the whole time.
For
But
real?
like, yeah, but you don't get 100%. Like the way my teacher does it is we grade each other on how well we work, like as our role in the group. So,
That's
but like no two people can have the same score. One person has to be above a 11. One person has to have below a 9, and one person can have a 10.
that's where like everybody has to collaborate and
Yeah.
really like do the math. Okay, so if I give you
Yeah.
11, you give him 11, who gives him, and you have to really.
No,
like,
but nobody can have the same score.
Oh, so you have to collaborate so that
So
you don't
yeah,
score
yeah.
each other.
So like you have to score on your sheet. Nobody can have the same score,
Oh.
and you have to do it out of 30. And then she has been switching up our groups because the grader has noticed that we have been doing that, trying to like.
What is this
and
world
so she's
coming
like,
to?
"You're not allowed to. If you were supposed to be grading someone's performance at work, you wouldn't be able to be like, oh, I'm gonna give you this grade. This is how you're doing."
I mean, if you
That's
met